Hello and welcome to the Rubber Duck Dev Show. I'm Chris,
And I'm Crustin.
and tonight we're going to talk about, we're going to do kind of a follow-up on the show we did on where do you put your business logic. We've decided it belongs in the database, so we'll talk about that tonight. But before we get into that, how was your week?
Super busy, even though it's supposed to be the getting up on the holiday times and things are supposed to slow down. Um, Working on two things I'll mention from different consulting stuff that I've been working on. One, working on a Rails upgrade. And those are always fun because like there's this one project that has about 2,000 tests. And so did the upgrade. And then, of course, there's things that fail mostly due to old gems. And out of those 2,000 tests, had about 100 that were failed. So that's about,
Ugh.
what was that, like 5% or so? But that's like 100 tests. So I have to go through and say, all right, what is this? Thankfully, I had a big uh, revelation with a couple of them that resolved like 60 of them immediately. Well, it fixed two things, actual things that ended up fixing 50 plus of them. So that's always great to have, but I still got a whole bunch of others I got to go through to figure out what the issues are with those.
Wow.
The other thing is that um one of my clients wanted to upgrade to Postgres 15, and the thing that they do their backup differently than any of my other clients. They basically use snapshots. So they don't use like, oh, what is it called? PG Backrest is a very popular third-party tool people use, or Postgres provides PG Base Backup, which is what I tend to use a lot. They actually didn't want to do any of that due to the volume of write-ahead log that they generate,
Mm.
basically a lot of the logs. So they wanted to go with just a once-a-day snapshot-based backup. And it's a huge database, it's, multi-terabytes. So they're basically just using AWS, um, EBS snapshots. But to do that, you have to put the database in a state such that it's ready to do a snapshot. Now they changed how that worked in Postgres 15. So it used to be you could start the backup to the database, you back it up, and then you call stop the backup. And no fuss, no frills, everything works.
Yeah.
Well, that doesn't work anymore in Postgres
Oh.
15
Oh no.
because that was actually called an exclusive backup. And they basically did away with that. But the problem with the new way of doing it, you have to state the start of the backup and then state the stop of the backup in the same database session.
Oh.
So I can't just in a bash script just say, all right, start the backup, and then 2 hours later run another bash command that creates a new Postgres session to say, okay, stop the backup. I now have to keep that database session running for as long as that snapshot takes to happen.
Oh. Ew.
And I mean,
Why?
I'm sure the third party backup tools handle this in a certain way, but I was kind of like, okay, well, how am I going to handle this? And I had seen some reports of other consultants that they had used like, I think coroutine. There's a way within a bash script to basically create two different processes and actually communicate and write data to it and then read back the responses. So I spent some time looking at that, and none of the blog posts on using this coroutine in bash worked at all. I was like, I found one article, oh, this looks promising. I try to replicate it. It doesn't work. All right, well, let me try the next article. That didn't work. Next article. That didn't work. I was like, oh my
Oh
gosh.
man.
So when you ever struggle like that, I said, all right, what's the hammer that I know and what's the nails I can hit?
Yeah.
So I basically said, all right, I'm going to create so I'm going to do the bash script, but what would normally just say, hey, just start the backup, it's actually going to run a Postgres procedure. And that is independent And so basically what that does is it has a built-in loop. So it says, all right, start the backup, then go into a loop, and actually created a table in the database too to manage backup state. So basically, the process of the procedure can check the database to see what the status is, has a snapshot finished. Then the script continues after it kicks off the procedure because it does it as a background job in the bash script. So that procedure is just running there waiting for the snapshot to be done. The bash script finishes doing the snapshot, and then it updates that table because again, that's the stored state for these two processes, and can say, all right, I'm done now. And now the procedure can see that, oh, it's done. All right, I can now close out the backup. So it's a little convoluted, but it works right now.
Well, as long as it works. I wonder why
So
they would do that. I mean, there must be a good reason, but I can't fathom what that would be.
yeah, I remember looking it up and reading the rationale behind it, but I've forgotten it.
Weird.
All I know is it's just a little bit more frustrating and less convenient for doing it. I mean, this is an atypical scenario for backing up the database. A lot of people don't do it this way. And there are some people that do it this way, and it does have its use cases. But like doing it this way, you can't have a point in time recovery. Like you can't bring the database back up to the point it was at 8:30 in the morning.
Oh, wow. Ooh, ew.
Well, because you're doing a snapshot.
Yeah,
And it basically the backup is at the point that the snapshot was taken.
yeah, yeah.
So it has a lot of disadvantages. So not a lot of people are going to do that. But given how this database is being used, they wanted to choose that path as opposed to the other one. So
Mm.
anyway, so what about you?
Um,
How's your week?
eh, I mean, good, but it's because end of year and we're just about to hit our code freeze, so we put our last production release out today. Um, so I guess technically we're in the code freeze now, but that means we're trying to get all the admin work done for closing out the end of the year stuff, all the retrospectives and all those things, and then start working on what initiatives we want to prioritize for January and start the year running on that. So it's all the little, hundreds of little things going on. No one thing is too terribly complicated, but when you've got 100 of them in the air at the same time, that gets a little nutty.
Yeah, like a big punch list.
Yeah. So but it's fun. I'm getting to dig into some fun things that are non programming related. I'm not fingers on keyboard a lot this week. Well, programming. I'm actually doing, like, one of the things I'm working on is getting the list together for platform of what initiatives we're going to want and putting those together into um, some voting presentations so that we can get together and kind of decide as a group, okay, how impactful is this? Um, how complicated is it to implement? And start looking at, okay, how should we prioritize these things based on all these different factors for them? So it's a fun thing to do once in a while. I wouldn't want to do that all the time, but it's a nice little break this time of year from banging on the keyboard. Um, so anyway, just lots of little
Okay.
admin-y things, not much
All right.
programming things, but it's good. And I'm super ready for a break. Christmas. I'm getting to take 2 weeks off this year, so that's really nice. Just shut my brain down for a little while. So, all right.
Yeah,
So,
that will be.
yeah. So on to putting business logic in your database. Everybody has these discussions about where to put your business logic. Database is not one I see come up very often. So so you kind of floated this idea for this show. So I'm going to let you start with giving your thoughts on, well, first of all, what does that mean really? Because you're not putting Ruby code in your database. Um,
Although
so,
you can quite easily put Python code in your database,
yes, you
at
can.
least Postgres.
Um,
And I'm sure there's a way you could get Ruby.
but it's not like you're coding your classes into your database. So what are we talking about when we say putting business logic in your database?
So it means putting a lot of decisions that basically is the underpinnings of how your application works in the database. Now, for example, I think of this as a continuum. And let's say I know an application, a web based application 20 years ago, written in ASP. And no, it wasn't even called that. No, it was Active Server Pages,
Mm-hmm.
Microsoft's Active Server Pages. This was pre .NET. So
Yeah.
this is before .NET. There was Active Server Pages. And this was a um, developed software program that whom I used to work for purchased. And how it worked was it had it wasn't PHP, well, no, it was Active Server Pages, and they would call stored procedures in the database. So they never made any select, insert, update calls. A lot of logic with regard to what tables get updated and how things were handled were done at a layer above the raw tables. So in other words, whenever a page was rendered, it would call an a stored procedure in the database. Whenever it needed to insert data, it would call a stored procedure to do that insert. And that may update multiple tables or do different things. So this is what you could think of a method in a Ruby program may do. So they put a lot of business logic in the database.
Yeah.
Now, let's say when Ruby on Rails got started, they just treated the database as just this dumb thing where you just throw your data into it and then you pull your data out of it. And they wanted no business logic at all in there because,
Mm.
I just need it as a data store.
Yeah.
So I think those are kind of the continuums. A lot of business logic in the database to, but don't put any business logic in a database. It's just a dumb hash store or whatever.
Right.
So like, and people are going to be on a continuum between that. And I think that's pretty much what people agree to today. There's some sort of continuum. And the where I tend to land on it is it's important to put business logic things related to data relationships in the database. I don't want to put all my other business logic in the database because that's just too hard to work through. And I'll get into some more details here. So I thought of this presentation about, okay, what are some of the different objects and how you can use them to essentially store business logic. So I was just going to kind of march through and discuss those. Did you have anything you wanted to talk about before I jump into that?
No, I don't think so. I Yeah, I think you're kind of hitting it on the head there where, because when I started, think about databases, it's just a data store. It doesn't do anything except hold pieces of data. But then, I have seen some things where there's just tremendous amounts of logic built into the database and it's doing so much that it, in my opinion, is too much because it gets hard to troubleshoot, it gets hard to trace things, and you've got no code on your platform to kind of
And
figure out what's going on.
more importantly, you have less tools to figure it out and diagnose what's going on.
Yeah,
Yeah.
exactly. Yeah. Um, so yeah, I think you're right. There's kind of a sweet spot between those two things where you get the benefits of the speed and the database doing databasey things on the database server rather than talking back and forth and wasting that time. But you also get the benefits of maintainability having code and that the database isn't too smart.
Yeah. And I think it's also team based. So different teams will choose where their sweet spot is, I think.
Yeah.
So Yeah, so like the first objects I'm going to talk about uh, are constraints. Now, I'll talk about constraints specifically, but this is any kind of way that you're constraining the data. So the most obvious way is using appropriate data types because those in and of itself constrain the data you put in. And you may say, our ID is essentially going to be no larger than an N4. So, okay, that's the data type you're going to use for that particular data. So that is kind of a business logic thing to do,
Yeah.
putting constraints,
Because you
on
are
your data.
enforcing some rules. Not everything is a
Exactly,
string, kids.
exactly, exactly. It's not like you're putting everything as a string. So you are putting some constraints on the data that you're putting in there.
Right.
But there are what like Postgres, which I'm going to focus on, actually talks about constraints. So there's null constraints. Do you want to put nulls in there or not? There are unique constraints. So that's clearly a business case of, hey, we shouldn't have, the form with the same field name, for example. Oh, here you go.
Yeah.
So those are unique constraints. There's also primary keys, which is a way to assure uniqueness as well as pull out data very quickly. There's also exclusion constraints. So exclusion constraints are great for like if you are trying to book a room and you have like a range data type, you can actually say, is this room available for these dates? So having that kind of logic in the database is so much easier to code than it is if you were to do it in your application. So it has that already built into Postgres being able to handle that kind of exclusion constraint. And the other thing of what is typically known as constraint is basically check constraints. So you can say whether something should have a minimum value or a maximum value or specific values. So if you have an ID you want to have be a capital letter and 9 digits, you can actually specify a check constraint to be that. So I would say all of this different class of constraints are a way that you're kind of putting some business logic into your data
Yep.
and into the database.
Yeah. And I think this is kind of a place where I see a lot of people forgetting about the fact that databases can do this kind of stuff, especially if you're in a Rails environment, because they put all these validations in Rails, but they don't back it up in the database. Those kind of validations should be in both places. You want those things in your database layer because if you write an API that accesses that stuff and it happens to not go through that Rails model, well, now you can screw up your data because you don't have the rules in the database.
And there's even Rails commands that bypasses, I think, they can bypass some of those validations.
Yeah, like doing a delete instead of a destroy.
Yeah.
You can do all kinds of nasty things.
So yeah, I know it's extra work because now you probably have to do validation at the front end level and now at your application or the Rails level, and then maybe at the database level. But
I mean, maybe, but it's one of those ounce of prevention, pound of cure things.
true. So, once you get up to a certain size and sophistication, then you're kind of, you're going to want to implement some of these constraints in the database as well.
Yeah.
So another area that's still kind of in the constraint field is foreign keys. So setting them up and defining your relationships of the data according to your business is important as well. So using foreign key constraints is another area to focus on.
Yep.
So another one is types. Now, databases handle this differently. I'm specifically going to be talking about Postgres types. So these are custom data types that you can create. Now, you could basically create any sequence of primitive types and stick them together, and that would be your own type. Like I've seen people do things like have an address type, which basically concatenates the address line fields and the city and the state and the zip. I think that may be pushing a little bit too far,
Yeah.
but it's there that you can use it if you find it beneficial. One thing I've seen it used for is basically you can create an enum type and have your different values in there, and then you create an enum using that data type that you just created in like a status field. So, like if you have 5 different statuses, you would create an enum type with those only those 5 statuses, and then you could use that status when you create your table.
And it's got the kind of the validation of those types built in
Right.
stuff so that
Those are the
somebody
only
can't
ones that can
stuff
go in there.
something. And I'm assuming too that like on a front end, you can probably pull from the database and get what are the available types.
Yeah. Yep.
Yeah.
Now, so those are types, and Postgres, different databases may call them different things. The other thing that Postgres has, it's a little bit, I don't like the name so much, but it is what it is called domains, which I consider it another custom data type. But what it is, it's a data type with built-in constraints. So, like the example in the Postgres documentation, you can create a postal code with pre-built constraints within it. And then you can essentially, when you're defining your data type, you just say use the postal code data type. And it
Yeah.
will automatically already have your constraints that have already been defined for the postal code. Now, back where I was talking about, if you have some sort of unique identifier that this needs to be um, 1 letter and 6 digits, well, you could define a domain that's called, the yo-yo ID or whatever, and it has those exact constraints. And now you could use that yo-yo ID data type in any other table in the whole system that you want. So again, this is kind of business logic that's applying some logic to how your data is laid out, but it's in very tied to the data.
Yeah.
So I think these are acceptable use cases for um, placing some of this logic in your database.
Right. And so these are kind of rules about particular pieces of data. So it's not like rules about flow or user
Yeah, no,
interaction. This stuff you're talking about is rules about particular pieces of data.
yeah, yeah. I think that's essential because again, it goes toward what the database does well. It keeps your data safe and consistent.
Yeah.
So those are the things that I think are kind of a no-brainer. Other people may disagree, but I think they're kind of a no-brainer for the database to do that sort of work.
Yeah.
The other area I thought about that is kind of a no-brainer is doing partitioning. Now, is this business logic? Not necessarily. Eh, not necessarily. But if you're going to do partitioning, whatever you do, don't put that logic in your application. Leave it to the database because it's
And
already built to separate the data into multiple tables that way.
I mean, and I guess it depends on how narrowly you define the term business logic, because this is kind of an architecture choice, but it can affect your customers and how you choose to implement other bits of business logic based on how you architect things like this.
Yeah. I mean, like, for example, if you say this particular data, we are only going to store 1 year of. So that's a business decision. Well, partitioning is a great use case for that because you could say partition the data by day or by month. And then when that year rolls around, you can drop the table
Yep.
for that month that has then past a year or the day, or by day. So, yeah. So the now we're starting getting into ones that are kind of like I wouldn't call no-brainers, but they're kind of, you kind of decide how you want to go.
Right.
And that is views. So should you use views? So I think they can be a convenience. Um, but I personally, I mean, even though I'm a database guy, the only use cases that I've used for views is in some reporting.
Yeah.
So there's a few reports I wanted to do, and it just made it more convenient um, to, because frankly, sometimes it's much easier for me to write an SQL query to do a report than it is to use some of Rails, the ORM to build the query.
Yeah.
That's just me and history where I've come from. But it is a reporting language, frankly. So
Yeah.
if it doesn't have to be too dynamic, I find it much easier to write a view and then just tell Rails or the web application, all right, just pull the data from this view.
Yeah, I've actually used views before when I've run into complicated data structures. You know, it's just tables related to tables all over the place, and things are not very obvious as to how they kludge together. So I've used views sometimes to write like, okay, here's this. I kind of redefine my own tables so that when I have to go write SQLs, they're simpler and make sense. Um, so I've kind of used the views as a I don't want to call it an abstraction layer because it's like an abstraction layer kind of on top of a nasty table structure, so that on the coding side things get a lot easier and cleaner, and people can understand what's going on in the code.
Yeah. So yeah, so I think those are valuable use cases for views on occasion. And then even from a performance perspective, sometimes utilizing materialized views. So basically, that's a view that you actually make into its own table by storing the data and refreshing it on a periodic basis. Sometimes there's business use cases for having that from a performance perspective.
Yeah.
And now the next one in kind of the iffy area, and but I think there are use cases for it, is triggers. So basically, a trigger is something that when you do something to a table, you insert, you update, delete, something else happens. Now that sounds suspiciously like a callback because you're like, all it did was update this value and suddenly 30 values in this other table got updated. What the heck just happened? That could potentially be a trigger at work. So for that reason, I would be very cautious about using triggers. But one where I have used it is two use cases. One is for keeping a TS vector column for full text search up to date. So something gets updated in a particular table or in another table, and a search string needs to be updated. A lot of times I use a trigger for that purpose. And although there are other tools like something called generated columns that can do that for you too. But if I actually had a situation where I actually had to use a trigger, given some different dictionary uses for a full text search use case. But anyway, I think that's an acceptable use case for triggers, is keeping something like that up to date so that you're fast. So that things like full text search is fast or your similarity search is fast. The other use case is a temporary use case. So, for example, you're needing to move from a table that has an int to a big int because you're going to run out of ints eventually. Well, you need to maybe replicate a table, backfill the data, and do things like so. That's a temporary use case of a trigger. It's there for the purposes of keeping data in sync and moving it around, but it's eventually going to go away. It's not something that's an inherent part of the application you're going to be sticking around. So and one thing I would definitely not do is put like a bunch of business logic in a trigger necessarily. So I would kind of actively avoid that. But what is your opinion on triggers?
Um, I, I've used them before, but you're right. What I've almost always run into with them is they turn into black box magic, where I don't know what the
Yeah.
hell just happened. How did this data get here? And it's not like you can trace through code to figure that out. You have to
Yep.
just go looking through the database and say, oh, well, there's a trigger there, duh. But that's not the first place you're going to look. You're going to be spending hours tracing through your code trying to figure out what the hell's going on with that.
What piece of my Ruby code updated this table?
Right.
And then the answer is none.
None. It's a trigger in your database.
Or it's exactly.
Well, who the hell did that? Me 6 months ago. You idiot.
So that's why I said they're a little bit like callbacks, and there's these mysterious things that, you know,
Yeah.
cause, ramifications down the line. So again, I have used it for those two use cases. Temporary use case for handling transition periods for data, and then the second use case is keeping um, like particular columns up to date for full text search or similarity search purposes.
Right.
So the next area is ones that, other than temporary use, I really wouldn't do, and that is basically functions. So, and when people think of putting business logic in the database, they'll probably say, "Hey, I'm going to write my own functions, and it'll be great."
Yeah.
I would generally not write functions for that purpose. I do write functions frequently for DBA tasks. Again, I think of these as more temporary, but they're not something that's going to be running and utilizing like a daily business logic use case usage. And now related to functions are procedures, which they're, again, databases handle them differently, but basically functions operate just within a single commit. And they can be as simple as, hey, take this value, like 2 + 2, do a sum of values or something. Whereas procedures can operate across or can have multiple commits in them so that a lot more work can be done. So what's your opinion on functions and procedures and whatnot?
So I've worked with a database at a job a while back that was that heavily used functions. It was an MS SQL database, but it was like almost everything that you did in the database was calling a function in the database, right? So the Ruby code was really simple, but you couldn't figure out how the hell anything worked because you can't trace database functions really. So it was nice from the perspective of it can simplify your Ruby code a lot, your ORM stuff, but making changes to that logic or what happens to data gets to be really tedious, because now I have to write a complicated database migration to basically drop that function and create a new one with some edits. But I have to go back and get that function to begin with, because you can't just, you know, can't really just, oh, add this field to this function. You've got to basically write the whole function again or copy it all. So you got to drop the thing, copy it all, make your edit. I've got a whole new migration. Now I want to find out how the hell this happened in my Ruby code. Well, I've got to go look in database code. So they can be useful for doing simplistic, foolish type things that are going to be um, not complex, that will always happen because of the definition of how you laid your data out, and that you don't want to have to do over and over in your Ruby code or your front end code. So they can be useful for that. But again, it kind of obfuscates how your data is being processed from your Ruby code. So it can get a bit dangerous using those things.
Yeah, I think simple functions like without side effects. Like all it is taking a few values that are being returned and maybe puts it in a different format. I think a simple function like that, if you wanted to do in the database, but that would be fine, if your team wants to do that. Um, but yeah, anything more than that, because like what you were just described sounded like the active server page application I was thinking about 2 decades ago,
Yeah,
where everything was a stored procedure.
right. And I think they're much safer and more useful pulling data out, modifying data as you're reading it, rather than trying to modify data as you're storing it. So, for instance, something like a function that will build you an entire address blob out of individual fields, that
Yeah.
kind of thing, because I'm not actually mucking with my data. Um, it, and then you get into, well, is that a view or a function or what? It depends on how you have to get there. But um, yeah, so,
But again, you're right. Working with functions is very frustrating with regard to what you were saying in terms of you can't just, hey, just replace this line and update. It's
yeah,
literally you have to recompile or, basically create or replace the whole function every time you do it.
right.
So
And
that in and of itself is just a difficult
it's a pain in the
exercise.
ass. I do see where they might be useful for kind of some back end regular maintenance type things. Where I need to do some stuff to the database. We need to do like our annual code clean or annual data cleanup and archival things and stuff like that. Where I don't want to have to write a crap ton of SQLs. So I've got these functions that'll do stuff, and I can just call the functions in a batch at the end of the year and let it
Yeah.
do some admin stuff. But from the front end of programming, I don't like to use them too much.
Yeah. Yeah. Yeah, I think we're on the same page
Yeah.
with regard to that. All right. So those are pretty much the ways in which I would tend to apply business logic to the database. So it's not really a lot of nothing about flow control, nothing about anything of that nature in the database. It's basically trying to keep your data secure and consistent. Now, I did want to follow up with two other points to mention. There is a way if you did store more business logic-y things in your database to get some more performance, but then a way to hurt performance. So a performance benefit of putting that I've heard of some teams do of putting more business logic in the database is when they're working with JSON APIs. Because Postgres you can give it a query and it can return raw JSON. So what these teams have done for some of their APIs is that they just query the database and they take the raw JSON back and they just ferret it right out to the end user. So they bypass the ORM. So there's no object relational mapper because so no objects need to be instantiated. So it's super fast. Um, and they don't have to build the JSON or do anything like that. It's just goes straight to them. And then you actually get to bypass a lot of Ruby processing. And you're essentially using C if you're using a Postgres database. So in general, it processes much faster than equivalent Ruby code would.
Yeah.
So that could be a benefit for like a JSON API, some performance benefits if you put that type of business logic in the database. Now, on the other side of it, what is the hardest thing to scale in your application? Or what are you going to hit the limit on in your application typically?
Uh, well, for us, most of the time it's memory, but I guess that depends on your
On which
architecture.
server, for example?
Well, on most of our um, our actual Ruby servers because of all the object instantiations.
Okay, but well, sorry, probably shouldn't have asked the question this way, but you could probably easily put you can easily scale application servers. You can get more application servers. You can get 15, you get 20, you get 50. You could
Oh,
increase
right.
the size of those quite easily. But the problem, if at least if you're running a relational database like Postgres or Oracle or MySQL, is there's typically, unless you're doing multi-master, there's typically only one database.
Yeah.
And if you want to make it bigger, you just got to keep going bigger and bigger, and you can't really scale out as easily as you can with application instances.
Right.
So that is where you can hit a barrier. The more business logic you put in your database, the slower it can do the things it is good at.
Right.
So handling concurrent access for thousands of connections to all of the data and keeping it consistent and locked appropriately so that not more than one person can change the data at once. So the more business logic you put in the database, you're going to hit that limit sooner.
Right. Yep.
And actually, that was a problem of this application, now that I think about it, the one from a couple of decades ago, in that it was actually the database that started having issues, the one that had all the stored procedures.
Yeah, and that used to be an even bigger problem before the advent of SSDs because your hard drive access was typically a huge bottleneck in your system, and every time the database would read or write something, it's going into the data into the hard drive. So the more stuff you put in there, the worse it got.
Yep.
Forgetting about caching and that kind of thing, there's stuff you can do in memory, but that's gotten to be a much less of a problem with SSD, but that's still a significant issue. Yeah.
Yeah. So it's basically because you can quite easily ramp up 50, 100, 200, I mean, however many application servers you want, or even worker boxes, you can go to the moon. But if you have a relational database and you don't have a service-oriented architecture, you've got one database. So the more that you ask it the more that you ask it to do, the more business logic you ask it to process, the slower it's going to be doing the other things that only it can do.
Right.
So that's an argument not to put too much business logic in your database.
Yeah. So I think the kind of the thinking here, um, the summary of this is you don't want to put things like flow control type business logic in your database. That doesn't make a lot of sense. Even though you
Yeah.
can do that to a point, probably shouldn't because there just isn't enough benefit there. You lose maintainability, you lose traceability, um, you slow your database down because that's not the thing the database is good at. So probably shouldn't put those kind of things in there. You probably should almost always put constraint type logic in there because that's what the database is for, making sure your data doesn't get screwed up. And that part of that are the constraints and the checks. So when most people talk about business logic, what they're thinking is more flow control and how the data is processed in the system. So if you define business logic like that, pretty much doesn't belong in your database. But that's not all your business logic because data and its state is part of really your business logic. And so the control of that data and the safety of that data is really the job of the database. We're making the assumption that we're talking about relational databases here. This is a different conversation if you're talking about, flat file structures or things like Mongo and stuff like that. So um, we're talking about relational databases, but that's the majority of apps are backed by relational databases. Um, so
Yeah, maybe it's more like, business rules.
Yeah.
as opposed to business logic. So definitely your business rules for data and their relationships, all that definitely belongs in the database as opposed to, trying to do something in your application.
Right. Now, do we say never put any business logic in your database? Not never, but if you're doing that, you probably ought to think hard about it, because there may be some back-end admin-y type things that functions would be good for, or that stored procs would be good for. But probably if you're doing functions or stored procs, it's not a good idea. It's
Yeah.
going to be a rare case. Especially if it's a stored proc or something that you're accessing from your code that does all your flow control, you probably want to look at that, because chances are that's not a good idea. So should you put business logic in your database? Yes and no. Depends on which business logic you're talking about. But flow control, no. Constraint, yes. Data safety, yes. Those kind of things, for sure. So that brings us about to the end of our time. That was actually kind of fun. I miss hanging out in the database world. I don't get to do that a lot anymore, and that's kind of where I started. So it's fun to dive back into that from time to time. Hope you guys enjoyed that. If you did, please make sure to like, subscribe, follow, depending on whether you're seeing this on YouTube or Twitch. We stream to both places. Also, if you prefer listening to this as a audio only podcast, you can find those podcasts everywhere that podcasts live. We strip the audio right out of this presentation and give you the same thing in podcast form, so you can find those all there. Also, you can find all this stuff on our website, rubberduckdevshow.com, and follow us on Twitter at DuckyDevShow, where I routinely say stupid things and also let you know what's going on during the week and what our schedule is. Speaking of schedules, this is our last show before the holidays. We are going to take a little break because at least one of us is pretty worn out and needs some downtime. So we will be back with Rubber Duck Dev Show on January 11th with Sebastian Vilgos. Pretty sure that's how you pronounce it. But he's Sebastian is the one that does Hanami Mastery, those courses. So we'll be talking to him about, well, at this point, what we're thinking about is talking to him about his note-taking processes, because he's done a lot of research on how to take notes and effective tools to use. And that's something I really suck at. So I'm very interested to have a chat with him about that. I did have a 2-hour Zoom call with him the last week, and it was really fun talking to him. He's a nice guy, so I'm looking forward to having him on the show. Also, next Tuesday morning, the 13th, I will be on their show to talk about streaming stuff. So I will be on there. It'll be 8 a.m. Eastern time, because they're running from Poland, so they'll be in their afternoon. So I will put some stuff on Twitter about links to his channel and all that stuff. We'll be on Twitch there. That should be a fun conversation. So we will be back on January 11th. I'm going to take a break from the coding with Chris as well, because I just need some time to spend with family and just hang out and turn my brain off for a little bit. But we will be back next year. I hope everybody has a wonderful whichever holiday you celebrate, and has lots of fun with your family and eats lots of good food. And we will see you next year. So until then, happy programming.
Happy programming.